Okay, welcome to today's WA2 revision, where we will be going through indices as well as coordinate geometry. So, the first topic we'll be revising on is indices. So, before I begin, let us go through the law of indices very quickly. So, first one, right, we have expressions involving same base. If we have same base, right, and we multiply them, the powers will sum. Okay, for example, 2 to the power of 7 times 2 to the power of 3, we'll get 2 to the power of 10 because 7 plus 3. Similarly, if we divide same base, what will happen is that the powers will subtract. So take note is always the first one minus the second one. So for example, again, 2 to the power of 7 divided by 2 to the power of 3, we will get 2 to the power of 4. Okay, next is adding same base. Okay, so take note, if the sign in the middle is a plus or a minus, you cannot apply any indices law, unfortunately. What you can do is to factorize instead. So look at this example over here. Let's say we have 2 to the power of 7 plus 2 to the power of 3. Okay, I cannot apply any of these indices law, right? What I can do is to factorize out the common term. So recognize that the common term here is actually 2 to the power of 3. So if we factorize out 2 to the power of 3, 2 to the power of 7, we will be left with 2 to the power of 4. And of course, factorize out 2 to the power of 3 from 2 to the power of 3, we will be left with 1. Okay, so this is how we can simplify indices with a plus or a minus in between. Next, it will be expressions involving same power. So now, if we have the same power but different base, okay, we can actually factorize out the power as such. So this will be a times b to the power of m. For example, 2 to the power of 2 times 5 to the power of 2, we can factorize out the power 2. And we'll be left with 2 times 5, which is 10 squared. Okay, so same concept for divide. We can factorize out the power. And the same thing, right? If the sign in the middle is a plus or a minus, we cannot do anything. And lastly, we have expressions involving powers. Now, the first one is our identity, which is anything to the power of 0 will always give us 1. Now, a very intuitive way to understand this is by by observing the pattern. So maybe let's say I use an example of 2 to the power of 0, to the power of 1, to the power of 2. On the left-hand side, I'll have 2 to the power of negative 1 as well as 2 to the power of negative 2. Okay, now 2 to the power of 2, very simple. The value is just 2. Same for 2 to the power of 2, it will be 4. And on the left-hand side, 2 to the power of negative 1 will be half, and 2 to the power of negative 2 will be 1/4. So, if we observe the pattern, how we go from 4 to 2 is to divide by 2, right? And how we go from half to 1/4 is also divide by 2. Therefore, to go from 2 to 2 to the power of 0, I must also divide by 2. So 2 divided by 2 will give me 1. Right? I can do this with any other base, right? Not only 2. I can do this with 4. I can even do this with 1/3. The result will always be the same, right? You will always see that anything to the power of 0 will give you value of 1. Now, next is our a to the power of m to the power of n. So how we simplify this is we simply multiply the powers together. So a very simple example to demonstrate this is, let's say I have 2 to the power of 3 squared. Right? By definition, this means 2 to the power of 3 times 2 to the power of 3. Okay? So this one, we already know how to simplify, right? Using the first law. Same base, different power, multiply, the powers will add up. So this will give us 2 to the power of 6, which is exactly the same as 3 times 2. So you can always use these simple examples to understand the formulas. And next is if we take the n root of a to the power of m, right? To convert this to power form, it will be m over n. So the key thing to take note is if we take the nth root of a, right? To convert this to indices form, it will just be a to the power of 1 over n. And if a has a power over here, right, we'll just simply multiply to the power by using this formula over here. Okay, so for example, if we take the 7th root of 2 to the power of 2, it will just simply be 2 to the power of 2 over 7. And finally, we have one of the most important formula, right? 1 over a over m will give us a to the power of negative m. So why this formula is so important is because a lot of times you have to get rid of the negative sign in the power. Right, and the only way to do that is to take the reciprocal. So for example, 2 to the power of negative 7 can be converted into 1 over 2 to the power of 7, vice versa. Okay, so now let's start with the practice questions. So for part A, I have 3 to the power of x times 27 to the power of x minus 2 divided by 9 to the power of 4x. So how do we simplify this expression? Is that recognize that actually 27 and 9 can be converted into base 3. Okay, so 27 is actually 3 to the power of 3. So let's convert that. Then we have power x minus 2. Same for 9. 9 will be 3 squared power 4x. Okay, then afterwards, we can apply our indices law, right? Same base, multiply. So the powers will add up. Okay, but before that, let me simplify this first. So if we have power to power, the powers will multiply. Okay, so this will give us 3x minus 6. Same for this side, you have 3 to the power of 8x. Okay, now we can simplify using the indices law. Same base, different power, multiply, powers will add up. So this will give us 3 to the power of 4x minus 6 divided by 3 to the power of 8x. And lastly, same base, divide, right? So the powers will subtract. So this will be power negative 4x minus 6. Okay, but don't forget, the question says leaving your answers in positive index form. That means we have to get rid of the negative signs. So how we can do that is, I can factorize out the negative in the power. So this will leave us with 4x plus 6. Okay, and remember, to get rid of negative sign, we just need to take the reciprocal. So this will give us the final answer of 3 to the power of 4x plus 6. Okay, next, part B. We have 2 to the power of x divided by 6 to the power of 3x times 12 to the power of x minus 1. So actually, there's many ways to do this question. But the way I will approach it is, I will first decompose 6 into 2 times 3, right? Same for 12. 12 can be decomposed into 3 times 4. So let's do that. So don't forget your brackets. So this will be 2 to the power of 3x multiplied by 3 to the power of 3x times, same thing for this side, we have 3 to the power of x minus 1 times 4 to the power of x minus 1. Okay. Then to make this expression simpler, I can choose to change it to a fraction form. So what I mean is this. So 2 to the power of x divided by this whole chunk, which is 2 to the power of 3x times 3 to the power of 3x. Right? Then we also multiply by this. So times 3 to the power of x minus 1 times 4 to the power of x minus 1. But recognize that 4 can be converted into 2 to the power of 2. So this will give us 2 to the power of 2x minus 2. Now we can simplify. Same base, multiply. So that will give us 2 to the power of 3x minus 2 times 3 to the power of x minus 1 over 2 to the power of 3x times 3 to the power of 3x. Okay, then we simplify further. So over here we have a divide. That means the powers will subtract. So we will end up with 2 to the power of negative 2. And over here, same thing, right? X minus 1 minus 3x. That will give us 3 to the power of negative 2x minus 1. Okay, and to convert this into positive index form, we just need to take the reciprocal. So this will be 1 over 2 square times 3 to the power of 2x plus 1. Okay, next is part C. So for part C, we have 8a cubed b to the power of negative 2 divided by 2a square times b. Okay, so same thing. To make it clearer, we can convert the divide to a fraction. So 8a cubed b to the power of negative 2 divided by 2a square times b. Okay, so now very simple already, right? 8 and 2 simplify into 4. A, sorry, a cubed and a square simplify into a. B to the power of minus 2 and b simplify into b to the power of negative 3. So we will have 4a b to the power of negative 3. Then to get rid of the negative power, just take the reciprocal. So take note, we don't take the reciprocal for the whole thing. Okay? Because this negative power only belongs to b, right? It doesn't belong to 4a. 4a already has a positive power of 1. So we'll leave it in the numerator. Or another way you can see it as this 4a times 1 over b cubed. Okay, so our final answer will be 4a over b cubed. Okay, and lastly, we have p cubed to the power of 4 times negative 5p square to the power of negative 5. Okay, so to simplify this, we can square this term first. Right, take note the negative sign is within the bracket. So if you square a negative number, it will turn positive. So this will give us 25p squared to the power of negative 5. Okay, then we can multiply them together. So p squared times p cubed gives us p to the power of 5. Q to the power of 4 times q to the power of negative 5 gives us q power of -1. So convert this into positive index form, we'll have 25 p to the power of 5 over q. Okay, question 2. We have 9a squared b to the power of 5 over 36 a to the power of -2 whole thing power -12. So what I'll do first is to simplify within the brackets. Okay, so 9 and 36 will simplify into 1 over 4. Right? A squared and a to the power of -2 will simplify into a to the power of 4 because 2 minus -2. That will give us 4. And then b to the power of 5 has nothing to simplify with, so we'll just leave it. Okay, so we'll have a to the power of 4, b to the power of 5 over 4 to the power of -12. Now we can bring in the -12, right? We can distribute to the numerator as well as the denominator. So we will have a to the power of -2, b to the power of -5 over 2 over 4 to the power of -12. Okay, but take note that 4 can be converted into 2 square. So this will actually give us a to the power of -2, b to the power of -5 over 2 over to the power of -1. Okay, so for this question, we are supposed to leave it in negative index form. Okay, so make sure all of the exponents have negative powers. Okay, for this question, we can simplify this part first. Right? P squared times P cubed, that will give us P to the power of 5 times R over Q squared. Then this divide over here, we can convert it to a times by flipping this fraction. Okay, so we will have times R and then Q to the power of 0. Remember, anything to the power of 0 will give us 1. So we'll just leave it as R. Right, over Q squared, P squared. So if we have fraction times fraction, right, numerator will multiply numerator, denominator will multiply denominator. So we have P to the power of 5 R squared over Q to the power of 4 P squared. Okay, then we can further simplify. P to the power of 5 and P squared will be left with P cubed. Lastly, convert it back to negative index form. So all we have to do is to flip the fraction again. So we have q to the power of -4 over c to the power of -3 r to the power of -2. Okay, lastly, question C. We have cube root of y multiplied by y to the power of -2 to the power of 3/4 whole thing squared. Okay, so obviously we will simplify it within the bracket first. So remember, cube root can be converted into y to the power of 1/3. Okay, then we multiply y to the power of -2 times 3/4. So that will give us -3/2 whole thing square. Then further simplify again, right? Multiply, so sum the powers. that will give us negative 7 over 6 squared. Okay, and lastly, distribute the power. So y to the power of negative 7 over 3. Next, question 3. Solve the following equations. So the hint given to us is to compare the exponents. So for question A, right, in order to compare the exponents, we need to make them the same. So 125 can be converted into 5 cubed. Okay, so this will be 5 to the power of 3x equals to 100. And then recognize that the powers are the same. So we can factorize the power out. So that will give us 2 times 5 to the power of 3x, right? And 2 times 5 will give us 10. So we have 10 to the power of 3x equals to 100. And 100 is actually 10 square. So 10 to the power of 3x equals to 10 square. Okay, now we realize we have the same exponents. Then we can just simply compare the power. So therefore, 3x must be equals to 2. And x will be 2/3. Alright, part B. Okay, same thing, simplify the bigger terms. So 81 can be converted into 3 to the power of 4. And 27 can be converted into 3 cubed. So now simplify the left-hand side. I will have 4x minus x plus 2. So that will give us 3x minus 2. Okay, take note of the sign change, right? Because we have 4x minus x plus 2. Okay, the minus must distribute to the plus also. Then now we can just compare the power since the exponent is the same. So therefore, 3x minus 2 equals to 3. So x must be 5 over 3. Okay, lastly, part C. Okay, so 625 can be converted into 25 square. So this will give us 25 to the power of 2 over k multiplied by, okay, so 1 over 25. Remember, in order to get rid of negative sign in the power, we just need to take the reciprocal. So, but same thing, we can also convert reciprocal back into negative power. So we will change 1 over 25 into 25 to the power of negative 1. So this will give us 25 to the power of negative k. And remember, 1 can be converted into any base to the power of 0. So let's change this to 25 to the power of 0. Okay, simplify the left-hand side. We will have 2 over k minus k equals to 25 to the power of 0. Okay, now we compare the exponents. So 2 to the power of k minus k equals to 0. So multiply by k both sides, you have 2 minus k squared equals to 0. K squared equals to 2. So k must be root 2 or k equals to negative root 2. Next, question 4. Find the value of P and Q for which this equation. Okay, so let's write it down first. Okay, so before I start this question, recognize that 21 can be broken down into 7 times 3, right? And 81 is just simply 3 to the power of 4. 49 is 7 to the power of 2. So let's simplify it. So we will have 3 to the power of Q times 7 to the power of Q equals to 3 to the power of 4 times 7 to the power of negative 2. Okay, because this is the denominator. So I will add the negative sign. Then 7 to the power of P can simplify with 7 to the power of Q. So that will give us 7 to the power of P plus Q times 3 to the power of Q equals to 3 to the power of 4 times 7 to the power of negative 2. So since the base is the same, right, 3 and 7, we'll just compare the exponents. Therefore, we can form two equations. Right, comparing base 7, we have P plus Q equals to negative 2. And comparing base 3, we have Q equals to 4. Okay, so sub back into this equation, we will get P as negative 6. So that will be for part A, sorry, part 1. For part 2, find the value of P and Q for this equation. So 7 to the power of 6P times 21 to the power of Q plus 7 equals to 81 over 49. So same thing, I will break down the 21 into 3 times 7, right? And this thing can be broken down into this. So 3 to the power of Q plus 7 times 7 to the power of Q plus 7 equals to 3 to the power of 4 times 7 to the power of negative 2. Okay, simplify the 7s. We will have 6P plus Q plus 7. Okay, then compare same base. So for base 7, we will have 6P plus Q plus 7 equals to negative 2. And comparing base 3, we have Q plus 7 equals to 4. So we know Q must be negative 3. Right, sub back in to this equation. So for P, we'll get P as negative 1. Okay, question 5. Show that this equation is divisible by 18 for all whole number x. So when the question says divisible by 18, right, the only way you can show that is to show that there is a factor of 18 in this equation, right? As long as we can show that this equation is 18 times some value, then this equation must definitely be divisible by 18. Okay, so let's try and do that. Okay, so remember, whenever there is a plus or minus sign, we cannot apply any indices law. We can only factorize. So figure out what's the common term. Right over here, this 4 to the power of x, I can rewrite this as 2 to the power of 2x. Then this one, I will distribute the 2 in. So this will be 2 to the power of 2x plus 4. Okay. Now looking at these three terms, the common term will therefore be 2 to the power of 2x, right? Because every single term has 2 to the power of 2x. So let's factorize that out. So this will be 1 plus 1 plus 2 to the power of 4. Okay, in case some of you are not clear, why is it 2 to the power of 4? Because if I take 2 to the power of 4 times 2 to the power of 2x, that will give me back 2 to the power of 2x plus 4. Okay, then simplify within the bracket, we will have 1 plus 1 is 2, right? 2 to the power of 4 is 8, 16. So therefore we have 18. So this will be 18 times 2 to the power of 2x. Okay, so we have achieved our goal, right? We have shown that this equation is 18 times something. Therefore, we can conclude it is divisible by 18 or all whole number. Okay, so question 6 will be similar as well. So that this equation is divisible by 7. That means we need to show that this equation can be expressed as 7 multiplied by something. Okay, so looking at these three terms, their common term will be 3 to the power of n. Because every single term has 3 to the power of n. So let's factorize that out. So first term will be left with 3 square minus 3 to the power of 3 plus 3 to the power of 4. Okay, simplify within the bracket. This will give me 63. So I will have 63 times 3 to the power of n. Okay, but then 63 is not 7. Okay, so we have to change it to be 7, right? So recognize that 63 is actually 7 times 9. Okay, so 9 we know is 3 square. So we can simplify these two terms together. So ultimately we'll get 7 times 3 to the power of n plus 2. Okay, therefore, we have shown that it is divisible by 7 for all n greater or equals to 0. All right, last question. We have the weight of 1 mole of iron in terms of kg, weight of 1 mole of silver in terms of grams. Find the mass of the following, leaving answers in grams. So the first one, 20 moles of silver. To be quite straightforward. Oh yeah, okay, so apologies. There is supposed to be a leaving your answers in grams and in standard form. Okay, so the last question is supposed to be a recap on standard form. So for part 1, 20 moles of silver. So just simply take 20 times 1.08 times 10 square. Right, if you use a calculator, you get the value of 2160 gram. Okay, so how do we convert this into standard form? Okay, so I'll do a bit of recap on the side. What is standard form? Standard form is basically A times 10 to the power of n, where A must be less than 10, strictly less than 10, and greater or equals to 1. Okay? And n is an integer. Okay? The power here, n must be a whole number. Okay, now, how do we actually convert numbers into standard form? I'll give you two examples. Example, right? Convert 1, 2, 3, 4 and 0.0123 into standard form. Let's start with 1, 2, 3, 4 first. 1, 2, 3, 4, right? We want to convert it into a form of a times 10 to the power of n, where a is a number between 1 and strictly lesser than 10. That means we need to shift our decimal point, right? 1, 2, 3, 4 has a invisible decimal point at the end, right? It's just simply 1, 2, 3, 4.0. So in order to achieve this form, I need to shift the decimal point all the way here. Okay, so I will have 1.234, right? Which satisfies the condition of A. Therefore, if I shift my decimal point 1 time, 2 times, and 3 times to the left, I will multiply by 10 to power of 3. So this will be 1.234 times 10 to power of 3. Okay. Similarly, for 0.0123, in order to achieve the condition of A, I need to shift the decimal point rightwards by 1 and 2 times. Okay, 1 time, 2 times. So if I shift my decimal point rightwards, I need to times 10 to power of -2. Okay, so you see the pattern. Shift left means positive power. Shift right means negative power. Okay, and you can even use your calculator to confirm this value, right? If you type this into your calculator, you should get back 1, 2, 3, 4. So applying the same logic back to our question, I have a decimal point 0.0 here, right? I need to shift this decimal point 1 time, 2 times, 3 times. So this will be 2.16 times 10 power of 3 grams. Okay, and this is how you convert to standard form. Now, part 2, 3 moles of iron. Okay, so we take 3 times 5.58 times 10 power of -2 times 10 cube, or 1000, because the mass of the iron is in terms of kg, right? We need to leave our answers in gram. So we need to times an additional 1000. Okay, so plug this into your calculator, you'll get 167.4 grams. Okay, convert this to standard form. I have to shift the decimal place leftwards by 2 times. So this will be 1.674 times 10 to the power of 2 grams. And lastly, for part 3, 20 moles of silver and 3 moles of iron, which is just simply the answers in part 1 and 2 summed together. Okay, so mass will be 1.674 times 10 to the power of 2 plus 2.16 times 10 to the power of 3. Okay, our calculator will give us the value of 2327.4 grams. Convert to standard form, we need to shift the decimal point 1 time, 2 times, 3 times leftward. So this will be 2.3274 times 10 to the power of 3 grams. Okay, so that is all for indices. Now we will move on to coordinate geometry. So let's do a bit of recap before we start on the questions. Over here we have the equation of a line, right? The general form, which is y equals to mx plus c. C is known as our y-intercept. Okay, so by looking at an equation in this form, we can tell the y-intercept of the line. Next, m will be our gradient. Okay, gradient, the definition will be change in y over change in x. Okay, and we can see the gradient from the value of m. And lastly, our x-intercept will be negative c over m. So recall, x-intercept is the point where the line touches the x-axis. And when the line touches the x-axis, the coordinate will be x comma 0, right? Okay. The y coordinate will always be 0. So all we have to do is to let y be 0. So we have 0 equals to mx plus c, right? And to solve for the x coordinate, we just make x the subject. So x will be negative c over m. Okay, that's how we get our x-intercept. Okay, next is our gradient. So recall that our gradient is change in y over change in x. Now, if my gradient is positive, it means that when x is increasing, y is also increasing. Okay, both are increasing. Therefore, my line must be upwards sloping. Conversely, if my gradient is negative, it means as x increases, my y is decreasing. Therefore, the line will be downward sloping. Okay, if gradient is equal to 0, it must mean that the change in y is 0. And for the change in y to be 0, the line must be horizontal. Okay, can you see? As x increases, there is no change in the value of y, right? It stays constant. Therefore, the line will be parallel to the x-axis or be horizontal. Next is m is undefined. So for gradient to be undefined, okay, our change in x must be equals to 0. Because since we cannot divide by 0, our gradient will be undefined. Right? For change in x to be 0, it will just be the opposite. Okay, it will represent a vertical line. Okay, as you can see, this vertical line, x value is constant, right? Therefore, the line will be parallel to the y-axis or be vertical. And finally, if we have two lines with the same gradient, it just means that two lines are parallel. Okay, next is our midpoint formula. So given the coordinates of point A and point B, in order to find the coordinates of the midpoint, which is M, all we have to do is to take the average of their x coordinate and y coordinate respectively. So if you look at this formula, all we are doing is finding the average of x1, y1 and x2, y2. Okay, for the first one, we take x1 plus x2 divide by 2. And for the y coordinate, we take y1 plus y2 divide by 2. Okay, so nothing too complicated here. Next is our distance formula. Okay, so unfortunately in EMath, this formula is not given, right? But don't worry, because this formula is something that you can easily derive it yourself. Okay, and I'll show you how. So to find the distance of a line, let's say line AB, A and B. Okay, I'll put B to have a coordinate of x2, y2, A to have a coordinate of x1, y1. Now, to find the distance of this line, we can make use of something we've already learned, which is Pythagoras theorem. And we know that Pythagoras theorem involves a right angle triangle. So let's create our own right angle triangle over here. Okay, and the distance of this vertical line is just simply y2 minus y1. Agree? Same thing, the distance of this horizontal line will just be x2 minus x1. Okay, therefore, applying Pythagoras theorem, we will have AB squared as y2 minus y1 square plus x2 minus x1 square, right? Which is the same as this formula. Okay, so don't panic if you cannot remember the formula. You can just easily derive it yourself in the exam. And lastly, if 3 points A, B, and C are collinear, okay, so the word collinear means lie on the same line. So if A, B, and C are collinear, it just means that gradient of AB must be equals to gradient of BC, which is also equals to gradient of AC. Okay, but take note, the converse is not true. Meaning you say, if gradient of AB equals to gradient of BC, it doesn't mean that ABC is collinear, right? Because I can provide you a counter example. For example, line AB and line B, sorry, CD. Okay, apologies. So the point I'm trying to make is that, let's say you have two lines with the same gradient, okay? We put AB and CD as parallel. This does not always mean that AB, C, and D lies on the same line. Okay, in order for the 3 points to be collinear, there must be a common point. In this case, we compare AB and BC, the common point will be B. If we compare AB and AC, the common point will be A. Okay, now let's move on to question 1. So for question 1, A, we want to find the value of theta. Okay, the question told us that the area is 8 units square. And we also know that length OA is the same as OB. So to find the value of theta, we can make use of trigonometry that we've learned in set 2, specifically Tuakaso. Okay, can you remember? So it says that tangent has the ratio of opposite over adjacent. So we can make use of that, right? The opposite of angle theta will be OB. The adjacent of angle theta will be OA. So we can form tangent theta is actually OB over OA. And since we know that OA equals to OB, that means OB divided by OA must be equals to 1. So tangent theta is 1. Right? To find the value of theta, we just take tangent inverse, and that will give us 45 degrees. Next is the coordinates of A and B. So recognize that A is just the x-intercept and B just the y-intercept. Okay, but the question never give us any information about the equation of line AB. So we need to make use of this information, which is the area is 8 square units. So let's try. Since we know that the area equals to 8, right, and the area can be found by half times base times height. So half times OA times OB gives us 8. And since we know that OA equals to OB, I can rewrite this equation as half OA square equals to 8. So OA square must be 16, right? OA will be equals to 4 or -4. But we reject, right? As OA, the length cannot be negative. So we just keep 4. Okay. Therefore, if OA is 4 units long, then A must be 4. Right? And since we know OB is the same as OA, then B must also be 4. Therefore, coordinates of A will be 4, 0, and B will be 0, 4. Next, part C, the equation of line AB. Okay, so recall that general form of equation of a line is y equals to mx plus c, meaning that if you want to find the equation of a line, you need two things. The first one is value of gradient. The second one will be value of y-intercept. So we already have the coordinates of B, which is the y-intercept. So automatically, we know the value of C will be 4, right? And to find the value of gradient, we can make use of the formula, right? Gradient is y2 minus y1 over x2 minus x1. Okay. So let me write down the coordinates of A, coordinates of B. Okay, so to find gradient, take y2 minus y1. So 4 minus 0 over 0 minus 4, which will give us -1. Okay, which is correct because we know that line BA is downward sloping. That means your gradient must be negative. If somehow you get your gradient to be positive value, then you know your answer is wrong because downward sloping must always give you a negative gradient. Okay, so now since we have the gradient of M, sorry, we have the value of M and the value of C, we just simply sub it in. So equation of AB is just y equals to -x plus 4. Okay, and for part D, simple, right? Length of AB, right? We can use the formula y2 minus y1 square plus x2 minus x1 square. So length of AB will be 4 square plus 4 square. This will be square root 32, which you can express it as 5.66. A round off to 3SF. And finally, part E. Question tells us that line AC is the line AB reflected about the x-axis. Okay, so how to understand this information, I will try and draw it out to help you visualize. Okay, previously we have AB, right? AB. Line AC is the line AB reflected about the x-axis. So just pretend the x-axis is sort of like a mirror, right? If I reflect it about the x-axis, I'll get another line like this. Okay, so this line will be AC, right? And since this is a reflection, then this distance from OC must be the same as the distance OB. Okay, and we know that point C is the point of intersection between y-axis and line AC. So now we want to find the coordinate of point C. Okay, since we already know reflection, this distance and this distance same. That means over here must be -4. So part E very simple. We can just state C as 0, -4. Okay, question 2. Now we have 3 pairs of coordinates, A, B, C. First question, find the equation of line AC. So same thing, to find the equation of a line, we need gradient and y-intercept. So let's try to find that. So first we can start off with finding the gradient of AC, okay, by using the formula y2 minus y1 over 2 minus x1. And that will give us negative 7 over 3. So take note, AC is downward sloping. So as expected, your gradient should be a negative value. To get a positive value, be sure to check your working again. And the y-intercept. Okay, so now once we have the gradient, we need to find the y-intercept, which is the value of C. So to find the value of C, I can simply sub in any point that lies on line AC. Because any point on this line will fulfill this equation. So over here, I have 2 choices, right? I can either use point A or point C, because obviously point A and point C lies on the line AC. So I will choose to use point A. Okay, sub 6, negative 6, comma 5. So I will sub y as 5. Then I will sub x as negative 6. Okay, then we can solve for the value of C, which is negative 9. Therefore, equation of AC will be y equals to negative 7 over 3x minus 9. Next, find the value of k such that P lies on the line AC. Okay, so since we know P lies on the line AC, that means it must fulfill this equation. So all we have to do is to sub k comma 1/3 into AC. Okay, so 1/3 will be negative 7 over 3k minus 9. So for k, we will get k as negative 4. Okay, so a very simple question. Part 3. Find the equation of a line that is parallel to AC and passes through point B. Okay, they already give us a very big hint. This line is parallel to AC. That means they must have the same gradient. Okay, so since we know they have the same gradient, right, I know that the equation of a line must be in the form of negative 7 over 3x plus C, right? C being the y-intercept that we have yet to find. And we can make use of this information, right? Since point B lies on this line, we can sub point B into our line. So sub 9 comma 5. So 5 equals to negative 7 over 3 times 9 plus C. Solving for C, C will be 26. Therefore, the equation of the line will be negative 7 over 3x plus 26. Okay, for part 4, find the length of line segment BC. So all we have to do is to use the formula. Okay, this will give us root 193, which we can express to 13.9 units. 3SF. Part 5. Find the area of triangle ABC. Okay, so to find the area of this triangle, we can simply take half times base times height. Our base will be line AB, right? And the height of this triangle is just this perpendicular distance h. So let me draw this perpendicular distance. Okay, so this will be the height of the triangle, right? Line AB is quite straightforward, right? We can see that A to B is from -6 to 9. That means the distance will be 15 units horizontally. And for H, we can see that go from coordinate 5, y coordinate 5 to y coordinate -2. That means the distance will be 7 units. Okay, therefore, our area must be half times AB times height. AB we know is 15, height we know is 7. So that will give us 52.5 units square. Okay, and lastly, part 6. Find the shortest distance from A to line BC. Shortest distance from A to BC. Okay, so the shortest distance will always be the perpendicular distance, which is this length. Okay, perpendicular distance meaning this will be right angle. So I will label this as D. Okay, length of this line as D. So to find the length of this line D, I can make use of our area because area is half times base times height. In this case, my base will be BC and my height will be perpendicular distance D. So therefore, I have half times BC times D equals to the area, which we have already calculated to be 52.5. Right? Sub in BC is root 193 from part 4. Okay, then we can solve for D, which is 7.558, round off to VSF. Okay, so this is for question 2. Next, question 3. Line 4y minus 8x equals to 20 intersects the y-axis at point B and the x-axis at point A. Find the area of triangle OAB, where O is the origin. Okay, so remember just now I said equation of a line will always be in this general form mx plus c. How come this equation of a line so weird, right? 4y minus 8x equals 20. Okay, this is just another form of expressing the equation of a line. As long as the power of x is 1, then this will be an equation of a line. So all you have to do is to turn this equation into y equals to mx plus c. How to do that? We just simply have to make y the subject. So let me show you. We have 4y minus 8x equals to 20. Okay, make y the subject, right? So I must move the 8x over first. Then I must divide by 4. So this will give me y equals to 2x plus 5. And actually this equation is just simply y equals to 2x plus 5 with a gradient of 2 and y-intercept of 5. So to help you guys visualize, we can actually draw this line out. The x and y axis. Gradient is positive 2, right? So we know the line will be upward sloping and y-intercept is c. So you must cut through C. So you must cut through 5. Okay, so this will be line AB, right? A is the x-intercept, B is the y-intercept. So this is point B, this is point A. Okay, origin will always be coordinate 0, 0. Now we are required to find the area of this triangle, OAB. So to find this triangle, we need the length of the base, which is AO, as well as height, which is BO, which we already have, which is 5. So now let's find the length of AO. And to find the coordinate of the x-intercept, we just have to let y be 0. Okay, so 0 equals to 2x plus 5. Solving for x, we'll have negative 5 over 2. That means the coordinate of A over here will be negative 5 over 2, comma 0. So now we can find the area. So half times base times height. Okay, take note, don't put the negative sign in because we are only looking at the length. This will give us 6.25 units square. Next, B part 1. Find the equation of line L1 that passes through point P and is parallel to the line with this equation. Right, so same thing. Whenever we have a equation of a line that is not in the form of y equals to mx plus c, we can simply convert it ourselves. So 2y plus 10 equals to 4x, right? Making y the subject, I will end up with 2x minus 5. Okay, since we know L1 is parallel to this line, that means the gradient of L1 must also be positive 2, right? So we know the equation of L1 will be y equals to 2x plus c. And recall, to find the value of c, we just have to simply sub in a point that lies on the line. In this case, it will be point P. So sub 6, comma P, we will have 8 equals to 2 times 6 plus C. Okay, so C will be negative 4. Therefore, equation of L1 will be y equals to 2x minus 4. Okay, lastly, part 2. Another line L2 with this equation intersects line 1 at point Q. Find the distance of line segment PQ. Okay, so if this sounds very confusing, you can always draw out. So previously we have line L1, right? L1 is positive gradient 2, so upward sloping. Y-intercept is negative 4. So it must be something like this. Okay, this value will be negative 4. This is equation L1. Then next we have line L2, right? With this equation, gradient negative 3. So the line must be downward sloping. And it cuts the y-axis at negative 5. So it should look something like this. Okay, negative 5. This is line L2. Now they tell us that L2 intersects like L1 at point Q. So this point will be point Q. Find the distance of line segment PQ. Okay, and we know that P lies on L1. So P will be somewhere around here, right? P 6, comma 8. Okay, this is 6 and this is 8. So we need to find distance PQ. In order to do that, we have to get the coordinates of Q. So to get the coordinates of Q, I can equate line L2 and L1 together. B part 2. First, I have line L1 as y equals to 2x minus 4. I'll label this as equation 1. Then I have line L2, which is y equals to negative 3x minus 5. I'll label this as equation 2. So I'm going to let equation 1 equals to equation 2. Now the reason for doing so is because at point Q over here, the y coordinate of L2 as well as L1 is equal, right? Therefore, I can let both y's be equal to each other. Hence, 2x minus 4 must be equals to negative 3x minus 5. So using this, we can actually solve for the x coordinate of Q. Okay, shift the x over and shift the 4 over, we'll get x as negative 1/5. Okay. So continue the working over here. So once we have the x coordinate of Q, to get the y coordinate of Q, we just sub into either equation L1 or L2 because Q lies on both lines. So sub into equation 1, we have y equals to 2 times negative 1/5 minus 4. So this will be negative 22 over 5. Okay, finally, we can find the length of PQ using the formula. And we can round off to 13.9 units USF. Okay, question 4. Line L2 with this equation shown in the diagram and intersects x-axis at point B. Okay, so now you know the drill already. If we have an equation not in the form of y equals to mx plus c, okay, we just have to convert it. So converting this, you have y equals to negative half x plus 3. Okay, now line L1 is parallel to L2 and it passes through A and intersects the x-axis and y-axis at point D and E respectively. Part A, find the equation of line L1. So okay, since we know line L1 is parallel to L2, that means the gradient of L1 must be same as L2, right? Which is negative half. So y will be negative half x plus c. And to find the value of c, we just need a point that lies on L1. In this case, point A. So sub negative 2 comma 5. So 5 equals to negative half x. Right? Negative half times negative 2 plus c. Solving for c, you get 4. Therefore, L1 must be y equals to negative half x plus 4. Next is coordinate of B. Okay, to find the coordinates of B, B is just the x-intercept of line L2. So all we have to do is to let y be 0. Okay, so for part B, let y be 0. So 0 equals to half x plus 3. Okay, this is the equation of L2. So now solve for x. We will have x as 6. Therefore, coordinates of B will be 6, 0. And let's write it down over here. 6. Part C. Now we have to find the value of k. If coordinate C, k, 1 lies on L1. Okay, since we know C lies on L1, it must satisfy the equation L1. So let's sub k, 1 into L1. So L1 is half x plus 4, negative half x plus 4. So 1 equals to negative half k plus 4. Right, solve for k, we will get k as 6. Next, part D. The length of line segment DE. Okay, so to find DE, right, DE is the x-intercept and y-intercept of line L1. So looking at the equation of line L1, we know that the y-intercept is 4, right? And the gradient is the same as L2. So our line L1 will look something like this. Okay, parallel, and y-intercept is 4. So this will be point E, and the x-intercept will be point D. So to find the x-intercept of L1, we just need to let y be 0. Okay, so 0 equals to half x plus 4. X will be 8. Therefore, D is 8, 0, right? So over here will be 8. And to find the length of DE, we can just use the distance formula. So DE will be root 8 square plus 4 square, which is root 80, round off to 8.94 units. 3SF. Okay, finally, part E. Find the area of trapezium bounded by line L1, L2, x-axis and y-axis. So they are asking for the area of this trapezium over here. Right, an easy way to find the area of this trapezium is that we can take the area of triangle OED minus the area of small triangle OB. Okay, this point we don't have a letter, so let me just label this point as. Okay, we can just minus area of triangle OBF. So let me highlight this. We can take the big triangle minus the small triangle. Okay, so therefore, area of trapezium equals to area of triangle EOD minus area of triangle FOB. Okay, to find area of triangle EOD, which is the big one, base is 8 units, height is 4 units. So half times 8 times 4. Then area of triangle FOB, base is 6 units, height is 3 units. So half times 6 times 3. And that will give us a answer of 7 units square. Okay, and that will be the end of this WA revision. Yeah, I wish you all the best for your WA2.